Hello everyone. So today our team will present about research methodology computer science with the topics of an evaluation of modern transformer based summarization model. So we will go to the our team first. Before we start, let's meet our team. We have Axel, Farhan, and also me, Valerio. So we go to chapter one. It's in the introduction. In this introduction, we will talk about AI. So AI is basically just the ability to do text that normally require human intelligence. But in this paper, we will focus on text summarization. The goal of text summarization using AI is to present essential information from long text in a shorter and easier to digest format. So basically, one of the example of AI is basically that is ChatGPT, right? ChatGPT is one of the example of a transformer-based model, which will be explained by Axel later. So solution that will given is the study purpose of how accurate some of the well-known text AI summarization, such as the GPT-3, T5, Pegasus, and BERT. And the two evaluation metrics that will be used on this research is raw score and BERT score.
Now, for the second chapter, we'll be discussing some of the related works. Next. Now, the first topic is about transformers. Now, as previously mentioned by Valerio, transformers is basically the backbone of all the models that we'll be comparing today in the paper. Now, I won't be discussing how exactly a transformer works because of the time limit, but basically why transformer made such a huge impact since its birth in the world of NLP is because transformers aim to solve some of the problems encountered by LSTMs or previous generation neural networks. Now, what exactly the problems were? In LSTM, it often struggles to generate long pieces of text because of memory retention problems, where the longer the text, the more probable the model will start repeating itself. And the second problem that was solved by transformers was parallelization, where the LSTM will require a very, very long time to be trained because of how it processes words, which is it processes words sequentially. Instead, in transformers, with the help of positional encodings and multi-headed attention, we can train it in parallel. Next. Now, here are the models that we'll be evaluating. First one is GPT-3, second Pegasus, next. And then there is BERT and T5. Now, all four of these models, as mentioned before, uses transformers as their backbone. However, it is important to note that each of these models utilize transformers in different ways or architectures. And that's why we want to evaluate these four models. Next. Now, this is just a diagram of how Pegasus utilized transformers. And this is how T5 utilized transformers. And again, we'll just skim through these. Next. Now, for the evaluation method, how exactly are we going to measure the accuracy of a summary? Well, the answer is simple. We'll be using a dataset that provides us with a reference summary or a summary that was written by human qualified professionals such as journalists, writers, or professors. And we'll be comparing the result of a generated summary by the AIs and the reference summary made by these humans. Next.
Next, we move to third chapter, methodology. Next. First, as previously mentioned, we have models. For our research, we will compare four different summarization models, which are GPT-3, T5, BERT, and Pegasus. We load these models using Hugging Face pipeline and use the CNN Daily Mail fine-tuned version for each model except for the GPT-3. Then we have stemming. Stemming is the process of extracting or transforming words into their base forms. In English, words often contain suffixes that can make it challenging for computers to process and compare them accurately, especially when comparing words in a reference summary and a generated summary. For example, if we have words like larger, largest, and largely, it would be considered as three distinct words by a computer. However, by applying stemming, these three words can be reduced into their base form, which is large. Next. Next we have datasets. So the CNN dataset is used to evaluate the generated text. The dataset consists of three fields, which are the original article, the summary, and the string ID. However, for this study, the string ID is not necessary as the original text will be manually provided to the models. Next, we have automatic evaluation. For our research, we will rely on automatic evaluation methods such as ROC and BERT scores. Due to challenge of incentivizing human annotators to evaluate a large amount of text. Next, we will use ROC scores, which assess token level similarity between reference and generated summaries, and calculate metrics like recall, precision, and F-scores. We will automate this process using ROC score library in Python, which also includes stemming capabilities. Next, we will use BERT score, a newer method that evaluates text based on contextual understanding rather than word matching alone. BERT scores utilize pre-trained context embedding to capture the meaning of the text and provide a more accurate. We will leverage the transformer library to adjust parameters for evaluating text using BERT scores. Next. So this is a flowchart of our works. Next.
Now, for the fourth chapter, we'll be discussing some of the experiments and results. Next. Next. Now, so here are the ROC score results of our experiments. Now, as we can see here, from the F measure of both the ROC1 and ROC-L results, we can see that GPT has the highest scores and by a considerable margin compared to the other models. Now, this does mean that GPT is extremely good at summarizing method at the token level. However, one other observation we can make is that GPT has a lower precision score than the recall score. Now, what this means is that GPT will often generate summaries that are way longer than the reference summary itself. Now, compared to T5, for example, that has a slightly higher precision score than the recall, which also does mean that T5 generates a shorter summary than the reference summary. Next. Now, here are the results for the BERT score. And as we can see, once again, GPT does have the highest F1 score here with a score of 0.88280. Now, although GPT is, it has the highest F1 score, the difference here aren't as significant as the one from the ROC scores. Now, what this actually means is that all four of the models that we evaluate here are contextually very similar compared to the reference summary. Next. Now, for the evaluation metrics, at first glance, it may seem like the BERT scores are more suitable to be used as an evaluation metric. However, we do have to keep in mind that BERT score itself is not perfect, simply because BERT still does depend on preferences. And what this means is that we don't actually have a reference data set to compare or to evaluate with BERT when the required data set requires long pieces of text, such as maybe 2 to 3 paragraphs. Now, the problem with long pieces of text like this is that it requires intensive human labor and time to collect the data set itself. Imagine multiple thousand of rows of data, each consisting 2 or 3 paragraphs of summary. Now, this is why we need another or a newer evaluation metric that does not depend on references that we can use. Next.
Okay, so I'm gonna talk about our last chapter is called conclusion. So basically, technology development has given rise to advanced AI, including text summarization models that aim to extract important information from long text to a shorter one. We use 3 models such as a Hugging Face and T5, BERT, Pegasus. Outside of the Hugging Face, we also have one model. It's called GPT-3, and the evaluation method is from the summary from the CNN Daily Mail, and the evaluation method is from the ROF and BERT. In the ROF state, we use stemming. Stemming is basically based on the explanation from Farhan, and the ROC score is used to word-by-word comparison, while BERT score is used to assess the meaning of the summarized word. And from the conclusion of the table above, GPT precision is indeed much lower than recall. This is because the summary generated by GPT tends to be longer, but on the contrary, T5 has a much higher precision than its recall, because the summary generation tends to be very short. Since these are abstractive summarization models, they will be encouraged to find a new words outside of the original article. Thus, if they generate a new words, ROF will be consider it irrelevant and will give a low score. The BERT result of its model are so similar that we cannot absolutely pronounce that GPT is the best. What this result proof, however, is that contextually, these four models are very similar. Although BERT seems to be more suitable option of an evaluation metric, it is not considered perfect because it's still reference-based. And the weakness of the reference base, it requires a human labor to collect data set. So there is no data set that is one document long. So we need a method that is not based on the reference base, but it must be a free reference. So these are the citation that we used for this paper. And that's all, guys. Thank you for watching.